Hello everybody, welcome to Unit 1, Days 2 and 3. It's all going to kind of blend together here, probably a couple of videos. So we're going to start talking about functions and operations of functions. So operations, addition, subtraction, multiplication, division. And basically we have a few identities here. First of all, our sum identity, f plus g of x is equal to f of x plus g of x. So our goal is going to be to split those up, evaluate each one separately, and then add them together. So you can probably see here difference is going to be very similar, except it's going to be subtraction instead of addition. Product works the same way. Quotient is our division. Okay. So for our first example here, I'm going to give you two functions. One of them is f of x equals x squared plus 2. So basically what that function says is you're going to take your input, you're going to square it, and then you're going to add 2. The other one, g of x, is x minus 3. So you can take your input and you're going to subtract 3. So two pretty straightforward functions. I'm going to go a little bit slower for the first one or two, and then I'm going to kind of go a little quicker for the rest, and you can kind of check your answers at home. So first of all here, the work that we expect to see, f plus g of 4, using that identity from up above, I want you to separate these. So what you're going to do is you're going to evaluate f of 4 plus g of 4. Okay, and usually I don't show all the substitution, but because it's beginning of the year and last year was kind of crazy with our shutdown and everything, here's how we're going to evaluate f of 4. You take your f function from up above, it says x squared plus 2, and you plug in a 4. 4 squared plus 2. All right, well 4 squared is 16 plus 2, that's going to be 18. Then I'm going to do g of 4. So I take my g function from up above, it says x minus 3, and I plug in a 4. 4 minus 3, well that's just going to be 1. So f of 4 is 18, g of 4 is 1, and add those up, I get 19. So f plus g of 4 is simply 19. So the next one now, f plus g of x, I want to take f of x plus g of x and add those together. So basically I'm not plugging in a number here, I'm just using the expression. So f of x is simply x squared plus 2. Plus g of x, which is x minus 3, and then I'm going to combine my like terms. So I get x squared plus x, and then 2 minus 3 is minus 1. So that's simply f plus g of x. Okay, so here's where I'll start going maybe a little bit quicker. F minus g of 7. So what I'm going to show now is the minimal amount of work you need to show. I want to see f of 7 minus g of 7. Now the rest can kind of be considered mental math, right? So for f of 7, you're going to go up to your f function and take 7 squared plus 2. So 7 squared is 49 plus 2, 51. And show me you calculated that to be 51. Minus g of 7. So g of 7 is going to be 7 minus 3, that's going to be a 4. 51 minus 4, what's that, 47? F minus g of x. Now here we have to be a little bit careful. We always have to be careful with subtraction because if you're subtracting a group, you need to distribute that negative. So first thing I'm going to do here is write this out as f of x minus g of x. F of x is simply x squared plus 2 minus, I'm going to put g of x in parentheses here. G of x is x minus 3. Again, here's why, because you're subtracting the whole group. So basically what you need to do is you need to distribute that negative inside. So if I distribute it inside, that's going to be a negative x, that's going to be a positive 3. So now, when I combine my like terms, I'm going to have an x squared minus x plus 5. And that's what I get when I take f minus g of x. Okay, well let's do some multiplication here. G times f of negative 2, what I expect you to show is g of negative 2 times f of negative 2. Okay, so g of negative 2, you plug in the negative 2 to g, you get negative 2 minus 3, that's going to be a negative 5. And f of a negative 2, you plug in a negative 2, you square it, you get 4. 4 plus 2 is going to give me a 6. So this will give me a negative 30. F times g of x is equivalent to f of x times g of x. Okay, well f of x we said is x squared plus 2 g of x is x minus 3, and your favorite four-letter acronym, FOIL, first, outer, inner, last. Let's go through that quickly. It's going to be x squared times x is x cubed. X squared times negative 3 is negative 3x squared. Inner, 2 times x is 2x. And last, 2 times negative 3 is negative 6. Notice here, no terms to combine, so that's just what we get. And let's wrap up here with some quotients. F divided by g of 5. So what I want you to show is f of 5 divided by g of 5. So again, for f, what we're going to do is we're going to square it and add 2. So 5 squared plus 2 is 27. G of 5, you plug into g, subtract 3. 5 minus 3 is 2. And if this, you end up with a fraction, you can divide it out if you want, but we like to leave our answers as fractions. Remember, the majority of this course is calculated and active, so just leave it as a fraction in simplest terms. And f divided by g of x, again, what I want you to show is just that you're going to take f of x and divide it by g of x. Not a lot of work here other than substitution. F of x is x squared plus 2. G of x is x minus 3, and obviously there's no way to simplify that expression, so we're just going to leave that. Now the last thing I want you to take a look at here real quick, how else could you evaluate f minus g of 7? So if you notice here, f minus g of 7, we've already done it, but I want you to take a look up here where we did f minus g of x, and we came up with this. So there is another method here. It takes a little bit longer, but the first thing you could do is find f minus g of x. So we did that already, and we got that x squared minus x and plus 5. And then second, we would sub in a 7. So that'd be 7 squared minus 7 plus 5. So they give us 49. Minus 7 is 42 plus 5, and that's 47, which is the same answer we came up with up above when we evaluated each one separately and then subtracted. Like I said, it's another way of looking at it. We prefer to have you guys show us splitting those up and then performing the operation. Okay, next. So this is a little bit more challenging, all right? I don't want you to confuse this with multiplication. This is called the composition of functions. Very important. Composition. I also want you to notice the symbol. Sometimes students have a tendency to confuse this with multiplication. The open circle is a composition, and notice what this is saying. This is saying f of g of x is equivalent to f of g of x. That's what that little o means, of. X is the input or the domain value for the function g. In this case, we do not evaluate separately. Again, I'm going to have you rewrite this. So we've got our same two functions. F of x is x squared plus 2. G of x is x minus 3. And I want you to evaluate f of g of 3. So what that means is we're going to evaluate f of g of 3. And first thing I want you to do is write down f of parentheses. And then the f function says to take something squared and add 2. So I'm kind of doing this in a slightly different order, but to show you the process. First thing we have to do here is evaluate g of 3. Okay, so what I'm going to do is I'm going to take a 3, I'm going to put it into the g function. So g of 3, I'm going to write it out here, you don't really have to. 3 minus 3 is just a 0. So where does that go? That goes here. So now I evaluate f of 0, which means put in a 0. 0 squared plus 2 is just going to be 2. That's how you do f of g of 3. You have to do the one inside function first, use that range, and put it into the domain of the first function. So let's just reverse the process here. G of f of x is g of f of x. Now we're using an x, okay? But don't let that confuse you. This is what we're going to do first. Well, there's nothing to do. There's nothing you're evaluating. F of x is just the function, x squared plus 2. So here's where it might get a little confusing. Your g function, because that's what we're talking about right here, g of something, tells you to take your input and subtract 3. So g is going to tell me to take the input and subtract 3, no matter what that input is. It could be a letter, it could be numbers. In this case, it's x squared plus 2. So I'm going to have x squared plus 2 minus 3. Then you just simplify. 2 minus 3 is negative 1, so that's just going to be x squared minus 1. Okay, and let's do one more here. F of g of x. So what this is telling me to do is f of g of x. So that's what I'm going to do first. I'm going to take that and put it into the f function. Well, g of x is simply x minus 3. So now, what am I doing? I'm taking the f function, which says input squared plus 2. And that input squared is going to be whatever's over there, x minus 3. So very quickly here, x minus 3 squared is simply x minus 3 times x minus 3. All right, I'm going to do this a little quicker. That's going to be x squared minus 6x plus 9. If you just do FOIL on that. And then don't forget you got to add your 2. And then just combine your like terms. X squared minus 6x plus 11. Hey everyone, welcome back to Unit 1, Day 2. We're going to kind of pick up right where we left off with compositions here. And we're going to talk about 3 new functions. I've got f of x equals 2x. So the f of x function is going to be taking 2 times the input. G of x is x plus 5. So g of x is going to be input plus 5. And finally, h of x is the square root of x plus 1. So we're going to be taking our input, adding 1, and then taking the square root. So work I expect to see here. F of g of 5. Remember, that's composition, that's not multiplication. Multiplication would be a closed circle filled in. So this is going to be f of g of 5, which means it's going to be f of some number. So the first thing you need to do is you need to evaluate g of 5. All right, so g of 5 is taking our input plus 5. It's going to be 5 plus 5. That's simply going to be 10. Then what we do is we take that and you plug the 10 into f. And you evaluate f of 10. So f is simply 2 times input. My input is 10. 2 times 10 obviously is going to give me a 20. Okay, so now let's take a look at g of f of 5. So you might think it's the same answer. Maybe it is, maybe it isn't. Let's find out. This is going to be g of f of 5. So in this example, the first thing we need to do is f of 5. So f of 5, that's 2 times the input. 2 times 5 is 10. Okay, so now this is going to be g of 10. You take your range, your output of f, and that goes into g. G says x plus 5, or input plus 5, 10 plus 5, that's going to be 15. So it's not 20. F of g of 5 is not the same as g of f of 5. So right now we know compositions aren't commutative. Okay, h of g of 3 is the same thing as h of g of 3 written like that. So first thing I need to do is what's inside those parentheses, g of 3. G function tells you to take that plus 5, 3 plus 5, that's going to be 8. And now you're going to plug that into your h function, h of 8. So the h function says take your input, add 1. So 8 plus 1 is 9. Then take the square root. Square root of 9 is 3. That simply gives me a 3. So these next two with the x's, this is where I think it might get a little bit confusing for some of you because I think numbers tend to be easier. But with the x, we're actually not plugging anything in. We're kind of simplifying. So this is going to be f of h of x. Now you don't really have to write this down, but I'm just showing you what we do first is what's inside the parentheses, which is just h of x. Well, h of x is just square root x plus 1. So what I need to do is I need to take that and plug it in here. So this is going to be f of square root x plus 1. Well, what does the f function tell us to do? Look up above, highlighted in yellow. The f function tells us to take 2 times the input. Remember, that's your input. So this is going to take 2 times this, x plus 1, which is just 2 square root x plus 1. Okay, you can just leave it in parentheses, doesn't really matter. Same answer. Okay, so last couple here with x's. H of g of x. So it's going to be h of g of x, which is equal to h of, you're going to take this g function right here from up above. So the g function is x plus 5, and that goes in here. So now what we're doing is we're evaluating h. So I need the h function, which says square root x plus 1. So I'm going to have the square root. Now don't think of the x as an x. Really, it's an input. So think of it as square root of input plus 1. Well, that input is this x plus 5. So that's going to go here. So I've got the square root of x plus 5 plus 1, which is the square root of x plus 6. So that's your composition, h of g of x. Well, let's see what happens here with g of h of x. So what this tells me to do is take g of h of x, which is going to be g of, what's h of x? You look up above, that's the square root x plus 1. And what does the g function tell you to do? The g function tells you to take input plus 5. So input plus 5 is going to be square root x plus 1 plus 5. Now notice this 5 is not underneath the radical. So this answer is simply square root x plus 1, then outside of the radical of plus 5. Different than h of g of x. So is composition of functions commutative? No. And then you can do something like C, F, and H. All you have to do is just show there's one example that doesn't work, and then it can't be commutative. Okay. All right. So let's move on to some graphing. We're going to use these graphs to perform compositions. All right. So I wish you didn't even see this part. So let's pretend you don't know what this is. Okay. And this graph right here on the left is f of x. The graph on the right is g of x. Now, it might be a little bit hard here. Let me actually zoom out real quick. Zoom. Let's try 75%. Yeah, maybe. We'll see. I apologize if this is too small. I kind of need to see the graphs and the questions. So I want you to find f plus g of 1. So f plus g of 1. Remember, this is an operation. All right, so now what we have to do is we have to be able to keep straight our operations versus our compositions. So that's an operation. That means I need to take f of 1 plus g of 1. Well, how do we do that graphically? All right, well, f of 1, this is my f function right here. It's this line. Remember, the 1 is the x. The f of 1 is the y. So what I'm doing on that graph is I'm going to where x equals 1. All right, let me use a different color here. And you go up to where it hits the graph, and then you go over to the y value. So f of 1 is 2. That's a 2. So I do the same thing over at g. So you go over to the g graph, and x is 1, and you go up or down till you hit the graph, and then you see what that y value is. That's also 2. So that's going to give me 4. So operations, addition, subtraction, multiplication, division, you do separately at the same number, and then combine them with the operation. Okay, so now B is a composition, f of g of 2. So what we need to do here first is we need to do g of 2. You have to do what's inside the parentheses first. Okay, so g of 2. So make sure you get the right one. That's this parabola. 2 is the x. So you go up till you hit the graph, then go across. The y is going to be 4. So g of 2 is 4. So now what do? You take that and you put it into this highlighted g of 2. So I need to find f of 4. So now I go over to the other function. Now x value is 4. You go up here, then you go over there to the y, and that gets me 8. So f of g of 2 is 8. Okay, let's clean this up for the next example. Now I've got g of f of 2. That's going to be g of f of 2. So the first thing I need to do is f of 2. Okay, so f of 2. My f function is a line. There's 2. I go up here, go across. That gets me a 4. So f of 2 is 4, and that's what you're going to put in right there. So now I do g of 4, and unfortunately this one I couldn't do visually. I can kind of cheat and see, oh, that's what it's supposed to be, x squared plus 1, and do this algebraically. I wish we could see all of that on the graph so we could truly do it graphically, but 4 squared plus 1, that's going to be 17. Don't worry, if this was a quiz or a test, all the information would be on the graph. I wouldn't give you one that goes off the grid. Okay, so let me zoom back out here. I want to take a few more minutes to do a couple examples, then we'll wrap it up for day 2. Just because this stuff is so important, and because you guys were a little bit cheated last year in A2 with the shutdown and maybe not as much practice as we normally would get. So if you notice here in example 5, all of these are compositions. All right, we've got 3 functions. Again, we've got our f of x here, which takes our input, subtracts 3, then take the square root. G of x is input squared plus 1, and h of x is 4 times the input. So example 5a, I'm going to take f of h of 7. And this I have to evaluate first. So you can show this down below, h of 7. So h takes 4 times the input, 4 times 7, that's going to be 28. Then what you do is you have to plug that into the f function, f times 28. Or sorry, f of 28. And your f function, it's the one highlighted in yellow. If you look up there, it takes input minus 3. So we're going to do this in our head. 28 minus 3 is 25. Then you take the square root of that. Square root of 25 is 5. So f of g of 7 is 5. H of g of x. And again, these are a little bit confusing when we have the x's in there. Basically, I'm going to take this g of x. I've got to use the green function from up above. I'm going to put it right in here. But notice our function notation. I still have function h, and I've got parentheses. But I'm going to replace the g of x with x squared plus 1. Now here's where it gets confusing. It's the second step, I think. What does the h function do? Well, the h function is my blue function. So this is the blue function, says 4 times the input. So my rule here is going to be 4 times the input. Well, the input's just whatever's in the parentheses, so that's just going to be x squared plus 1. So when I multiply that stuff out, you can distribute here, you get 4x squared plus 4, and that is as much as you can do for that one. So our last one here, g of x. This is kind of interesting. This is going to be g of x. So the first thing I need to do is this. Plug in your expression for g of x. Okay, well that's going to be g of x squared plus 1. So again, here's the confusing part. So now what do? Well, now we use our rule for g, because that's what's on the outside of the parentheses here, which says input squared plus 1. So that's why I don't like you to think of them in terms of as x's. They're really inputs. Input squared plus 1. Well, what is that input? Well, that input now is x squared plus 1, and that's what's got to go in here. So I got x squared plus 1 squared plus 1. All right, we're not going to make you multiply all this out. That's fine if you just leave that as your answer. I'm just going to write it here so it's not quite as cluttered. X squared plus 1 squared plus 1, and that's fine if you leave it like that. You don't have to FOIL that out. That's good. All right, so we're going to stop there for day 2, Unit 1, day 2. And tomorrow we're going to introduce inverse functions and how to determine whether functions are inverses. Once again, thanks for hanging in there, and don't hesitate to reach out if you have any questions.